Okay, so up until this point, we've looked at a lot of rules and laws on exponents and operations on exponents, and we've looked at roots and operations on roots. We've looked at rationalizing the denominator and so forth. So what we've done up until now is we've laid out a foundation which can help us to solve more complex sort of equations. And that brings us to the next part, which is called exponential equations. And as the name refers, it's just equations containing exponents. So up until now, we've actually focused more on simplifying sort of not really equations, but expressions, but we can actually go now and solve different types of equations. And so these are the this is sort of my summary of the 5 types of equations for grade 11 that are important. And we'll be looking at each of these 5 and how to solve them, how to identify them, and so forth. Okay, so let's start with the first type of equation in this video. So we'll be looking at what we call same base equations. Now, what do I mean by same base equations? So let's just refer back to do some revision. Say we have something in the form of a to the power b, right? We know that we can refer to b as being the exponent, okay, and a is what we refer to as the base. Okay, so if I'm talking about something or things that have the same base, we're referring to this a over here. Okay, so whatever value of a they have, it will be the same. Okay, so let's look at a very simple example. So say we have something like 3 to the power of x is equal to 3 to the power 2. So what we have here is an equation, right? Because we have the equal sign. And we have a same base equation, in fact, because over here on this side, on the left side, we have a 3 as a base, and on the right side, we have a 3 as a base as well. So what this means now is that because we have a similar base, all we have to do is we can set the exponents equal to each other. So in other words, 3 to the power x equals 3 to the power 2, which means that x has to be equal to 2 in order for this equation to be valid or correct. So x is equal to 2. And this is a very simple example of what I mean by same base equations. Okay, so let's push it up a notch. So say we have something like 2 to the power x equals 16. So just note that the goal for us with these types of equations is to find a common base, is to find a similar base. Okay, so looking at both the left and the right side, on the left side we have a base of 2 to the power of x, okay, and we want to solve for x. But on the right side we have a 16. So as before, we don't have 2 similar bases on both sides at the moment, so we can't go and set any exponents equal to each other. However, being the smart mathematicians we are, we see that on the right side we can simplify 16 into 2 to the power 4. Right, we can simplify it into something that has a base which is the same as what we have on the left side. So on the left we have 2 to the power x, and on the right we have 2 to the power 4. And thus x has to be equal to 4. Okay, so by now we should have recognized the pattern. So what we're doing is we're trying to sort of simplify everything in such a way that we have common bases. And then we can simply take the exponents and set them equal to each other. So looking at this next example, what would we do in this case? So on the left side, we can see we have 3 to the power x, okay? 3 is in it's in the most simplest form, or the simplest base, okay? We can't really break that down to anything else. And on the right side, we have 1 over 81. So our goal is to find a common base. So what can we do? So as I said, the left side is fine as it is. So we're going to have to go and manipulate on the right side. But what can we do on the right-hand side? Well, as we've learned before in our previous rules, what we can do with 81, we don't really want to have a fraction because we want to find a base raised to some exponent. So what we can do is we can flip this around and we can write this as 81 to the power minus 1. Okay. If you are confused about how I did this, just refer back to the previous videos. Okay, so now we have 81 to the power minus 1, but we still don't have a common base. So our sort of goal base is to get a 3, right? So can we break 81 down to something even simpler? Well, yes, we can, because 81 we can simply write as 3 to the power 4. So we'll have 3 to the x is equal to 3 to the power 4. Taking note that this whole thing is technically raised to the power of minus 1. And so we can simplify this. 3 to the power x equals 3 to the power. So we'll multiply the exponents. So we'll have 4 times minus 1 is minus 4. And now we have exactly what we want. We have a common base of 3. And now we can set the exponents equal to each other. So we have x and minus 4. So x is going to be equal to minus 4. Okay, so let's look at a bit of a harder example. So what I want you to notice, or what I think is really important, is to be able to identify the type of equation that you are dealing with. Because in the real world, in tests and exams, your teacher is not going to tell you to solve this same base equation or the K-method equation. You're going to have to know what is what. So it's really important to identify what you have. So firstly, I want you to notice, of course, right now we know that this is going to be a same base equation because it's the section, or it's the video that we're dealing with now. But what I want you to notice is that we don't have any pluses or minuses. Okay, we're simply multiplying different values with each other. Okay, usually when you have pluses and minuses, you'll get to factorization, okay, which we'll look at in the next video. But in this case, you'll see we're only multiplying. Okay, so that's something to look out for when dealing with same base equations. So remember, our goal with these types of equations is to get a similar base throughout. Okay, so let's scope throughout and let's see what we have. So here we have a 16 as a base, okay, raised to the power of x. Here we have a 2 as a base, raised to the power x plus 1. And on the right hand side, we have the 5th root of 4. Okay, so instinctively, you should see that your most simplest base that you have throughout is this 2 over here. So the goal will be to try and get all the other bases to a 2 as well, so that we can simply set the exponents equal to each other. Okay, so let's see what we can do about this. So 16 is quite easy. We've done this before. We can change that to 2 to the power 4. So that will become 2 to the power 4x. Okay, and we'll keep the 2 over here as it is because it's already in its simplest form. So we have 2 to the power x plus 1. And now on the right hand side, if you just refer back to our operations on roots, or sort of when we were dealing with roots, we can change this to 4 to the power a 5th. Okay, and this helps us now because now we have some sort of base raised to a power, so we can try and simplify that to get a 2 as well. So the first thing I want to do on the left hand side is just to simplify this expression. Because we have a common base of 2 and we're multiplying these two together, we can simply add the exponents. So we'll have 4x, so we have 2 to the power 4x plus x plus 1, which will give us 5x plus 1. Okay, and on the right hand side we have 4 to the power of a 5th. But now we want to try and get a 2 on that side, and we know that 4 is technically 2 to the power 2, right? Taking note that this whole thing is still raised to the power of a 5th. And so what we'll do is we'll just multiply the exponents. Okay, so we'll have 2 to the power 2 over 5. Okay. So now what do we have? We've simplified this whole expression, or this equation, such that we have a common base, in this case 2. And now it's easy. Now all we do is set the exponents equal to each other. So on the left hand side we have a 5x plus 1, and that'll be equal to 2 over 5, which is on the right hand side. Okay, and now it's pretty much very straightforward. Okay, so all we're doing now is just solving for x. So we'll take the plus 1 over to the other side and subtract 1. So we'll have 5x is equal to minus 3 over 5. Okay. And then all that's left to do is to divide by 5. So if we do that, we'll have minus 3 over 5 divided by 5. But we can multiply and say 1 over 5. Okay, tip and times. And then our answer will be equal to minus 3 over 25. Okay.